let's talk about the conversion of NFA to DFA. Like this is an NFA. Here is the states from 1 to 5. The alphabet is AB, start state is 1, final state is 5. From state A, if we take A, from state 1, if we take A, we will able to go to 3. For from state A, if we take B, we will do not able to go anywhere. If we take epsilon, we will able to go to state number 2. From state 2, if we take transaction A, alphabet A, we will able to go to the state number 5. From if we take the alphabet B, we will able to go to the state number 5 and 4. From epsilon move, the move is not defined. From 3, we the for alphabet A, we will not able to go to anywhere. For B, we will able to go to the state number 4. For epsilon move, the move is not defined. For state number 4, we will able to go to the 5 if we take the alphabet A. For B, we will also able to go to the state number 5. Okay. For conversion to NFA to DFA, I will actually use the subset construction method. The first rule of subset construction method is firstly, from initial state to take epsilon move, if we able to go in the new state, and then we have to merge this state into one state. Like here, from 1 we take epsilon move and we are able to go to the next state, which is 2. So we have to merge this state into one state, and we see that this state name is 1, 2. This is actually the transaction table for this NFA. Okay, and this column is for the states, this column is for the alphabet A, and this column is for alphabet B. Now we have to define our move from for a newly created state 1 to from 1, we if we find the alphabet A, we will able to go to the state number 3, which I write here. From 2, if we find alphabet A, we will able to go to the state number 5, which is here. So this is now a new state we will find, which name is 3, 5. Now for B, now for alphabet B, from 1 we will not go to anywhere from if we find alphabet B, but from 2 we will able to go to the state number 4 and state number 5 if we find the alphabet B. So we will find another new state, which is 4, 5. Now if we find any new state, we have to write it to the column of state. Right here, I found the two new state, which is 3, 5 and 4, 5. So I have to write these two state into this column. Now I have to see where I can go from state 3, 5 for the alphabet A and B. First, for state 3, 5, we cannot go for the alphabet A, but for alphabet B, from 3 we will able to go to the 4. From 4 we will from 4 for alphabet for 5 for alphabet B we will not able to go to anywhere. So I find another new state which is 4, so I write it to here. Now the uh, for the transaction of state number 4 and 5, from 4 if we get the alphabet A we will able to go to the state number 5, and from 5 if we get we will not able to go to anywhere from for any alphabet. Same thing goes here. From 4 if we find the alphabet B we will able to go to the state number 5. From 5 we will not able to go anywhere. 5 is the new state from here, so I write it in this column. Write it in this column. From 4 if I get the alphabet A I will able to go to the state number 5, and from 4 if I will get alphabet B I will able to go to the state number 5, but 5 is not the new state, so I have not to write it to this column. Okay, from 5 I will not able to go anywhere for the alphabet A and the alphabet B, so I have test up here. So 1 comma 2 is our initial state for the DFA, and 3 comma 5, 4 comma 5 and 5 are the 3 final state, because these are the related to the NFA's final state 5. So our DFA's have 3 final state which are 3 comma 5, 4 comma 5 and 5. So this is our DFA. Now take a look at another example. From 1 from initial state I cannot see any epsilon transaction, so we cannot worry about the first rule of conversion of from NFA to DFA. So I take 1 as a new state and name it to A. From A I will able to, from capital A I will able to go to the state number 5, 2, 1, 3 and 4 for alphabet small a. For alphabet B, small b, I will able to go to the state number 5 and 4, so I name it and this state to C. From B for alphabet small a I will able to go to the state 1, 2, 3, 4 and 5. So this state is actually the state, this state is actually the V, so I write it here. From B for transaction for alphabet small b I will able to go to the state number 4, 5 and 3. So this is the new state, so I name it this state to D and write it to here. From C, which is 5, 4, I will able for alphabet A I will able to go to the state number 5 only. So this is the new state, I name it to E, and for alphabet small b I will able to go to the new another new state which is 4 and I name it to F. From D, which is 5, 4, 5 and 3, I will able for alphabet A I will able to go to the state number 2, 5, this is another new state which is G, and from D for alphabet B, I will able to go to the state number F, which is 4. For E, I will for alphabet A, I will not able to go to the any new state. For alphabet B, the result is same. From F, I will able to go to the newest the state E for alphabet A. From F for alphabet B, I will able to go to the state number F, which is actually the 4. From Z, if we find the transaction of small a, I will not able to go any new state or any other state. For small b, I will able to go to a new state which is H, which is 3, 5, and I name it to H. From H, if I find transition a, small a, I will able to go to the another new state which is 2, and I name this state to I. For alphabet B, I will not able to go to the any state. Sorry. From state I will able to go to I will not able to go any other state. For alphabet B, I will able to go to the state H. Now this is actually the DFA which I find in this transaction table.